So I will tell everybody real quick before we get started with tonight's program, stick around after Jon's talk. We might have a little bit of an open discussion about a pesticide related bee kill that occurred this past week over near Topeka. So we might get some updates on that, maybe talk with some of our experienced beekeepers on what to do when that happens and how to see that. So be sure and stick around. So tonight we have a really great program. I'm excited. Jon, I'm not even going to attempt to say your last name, so I'll let you introduce yourself and give you a little bit of a history. But I saw Dr. Jon at EAS last year in Kentucky. Did a really interesting talk about brood pheromones. I've always kind of had it in the back of my mind to invite him to our meeting. And this month we weren't able to get the fairgrounds, and so that's why we're having a Zoom-only meeting this month. And I didn't know this either, but I was reading my honeybee biology book last night and noticed that Dr. Jon is responsible for the illustrations in this book, if you did not know that. And if you don't have this book, it's a good book. I hope it's showing up on my screen. I don't know if it's blinking out or not. It's a good book. But Jon, I saw your name attached to the illustrations in that. So,
Well,
so if you're ready.
I've done a number of books with Larry Connor and a couple of other people. I'll tell you that there's supposed to be a new version of that book coming out soon. So I probably shouldn't tell you not to buy the second edition, but wait for the third. So,
okay.
Don't tell them I said that though.
All right.
Oh, is that the third edition there? Somebody's holding up.
Got it. Yep.
Well, I don't know what edition this is. What?
Okay. Robert Burns is holding up a version. Okay. I haven't even seen the third edition yet, so great job.
Yeah, I don't know what this one's 2013. This is 2013, so there might be another one coming out.
Yeah.
Well, good. Well, I will turn it over to you if you want to give an introduction. Let us know how you got into beekeeping, and let's talk about some pheromones.
Okay. Well, my name is Jon Zawislak. I'm with the University of Arkansas Division of Agriculture. And I got into beekeeping completely by accident. I started out studying plants, and I took a job working for a professor one summer who needed a person to identify plants that were host to some insects that he was studying. And I wound up working for him for 8 years. And in that process, he taught me about honeybees, and I decided, this is pretty good stuff. I might just go back to school. And when I did, I started studying bees and varroa mites. And just as I was about to graduate, all the headlines came out that all the bees are dying, colony collapse. It was all the gloom and doom. And so the Division of Agriculture offered me a job as an extension honeybee specialist. And you want to talk about the right place at the right time with just the right credentials. I had them. So I've been there now for about 13 years. So the decline of honeybees has been very, very good for me personally, I guess. But I enjoy honeybees. I enjoy beekeeping. I love talking about bees. I love bee biology. I think they're just the most fascinating creatures. And there's lots of different aspects of their biology that just continue to amaze me. So tonight, I'm going to talk to you guys a little bit about honeybee pheromones. So I'm going to try to get that onto my screen. Can you guys see that?
Yeah, we do.
Yep, we can.
Okay. All right. So bee pheromones. Honeybees, we know they communicate in lots of different ways. So we know about, some of them probably, like the waggle dance. We're all familiar with that. And honeybees also have another signal they call a stop signal. When dancing bees are sending their hive mates off to someplace dangerous, maybe there's a predator there or something, a bee comes back and says, stop. She'll actually headbutt a dancing bee and say, don't send anybody else there. There was a spider on those flowers or something like that. So they signal that way as well. There's also a lot of vibrations that bees can detect. And sound waves are vibrations, and when bees are dancing on the comb, then it sends off vibrations. We can hear some of the signals. You've probably heard of queen bees piping and things like that. So there are signals called vibroacoustics that kind of cover a range of sounds we can hear and some that we can't. And there's actually quite a bit of research right now into vibroacoustics and being able to detect the pitch of the buzz that the bees are making and trying to interpret that. So you've probably seen a lot of the devices now that you can put on your hives to measure their weight and their humidity, and there's some that are trying to listen to what the bees are saying, with the intention that if we can figure out what those signals mean, then we can interpret them and we can know what the bees are about to do. Unfortunately, we're not quite to that point yet, but ideally in the future, maybe we could tell that bees are getting ready for a swarm or something like that. But of course, right now, all we can tell from most of these instruments is that, well, it's already happened. So good luck next time. But maybe you'll be able to get an alert on your cell phone sometime that tells you have 5 minutes, so you can race across town and try to stop that. So good luck with that, right? But a lot of the ways that honeybees communicate have to do with chemical signals. So pheromones. There's lots of these, and a beehive is you could say it's a very noisy place as far as pheromones are concerned. Pheromone languages are very complex, but they're really ideal for what's going on in a beehive. It's a dark place. You've got tens of thousands of individuals all doing different things. So I love this photograph here on your screen. This is all the bees are headed in one direction. Looks like they're all going out except for that one bee. What's up with her? She didn't get the message that one bee is going the wrong direction, but everybody else seems intent on something. You can actually listen in on a lot of these messages that are going on in a hive, and there's some technology that goes back to the 1950s called an electroantennogram. You can put literal electrodes on a bee's antenna, and you can measure the amount of signal going through those nerves, and you can blow odors across an insect's antenna. They can do this with honeybees and lots of other insects, but this is how we can figure out exactly which scents really activate a bee's brain. So we know about different pheromones and how they key into other odors, that they might prefer one odor over another. This has been really useful in pest control for finding different mating pheromones for pests that we can use to trap things like gypsy moths and other things that are real bad pests. I don't know how much cotton they grew in Kansas, but over here it was a big deal, and the eradication of the boll weevil was a big deal. And of course, they did that using these pheromones. So you can do this with honeybees as well. If you look at a bee colony as a group, sometimes we call it a superorganism. It's thousands of individuals, but they seem to be able to make these unanimous decisions. It seems like they're acting as one unit, even though it looks like it should be just utter chaos in there. It's highly organized. So as a colony, this collective group of individuals, it has to function as a single organism. So it has to regulate itself and all of its activities, and it has to maintain the ability to make decisions in order to stay efficient. So of course, that requires effective communication. And so there's multiple systems of signals and feedback loops that are constantly being applied to each individual bee, as well as from individual bees to the whole colony, pretty much all the time. And as I said, these pheromones are ideal for that. It's very highly advanced, it's elaborative, and it's perfect for transmitting information throughout the bee colony. So, as I said, that we can send signals to and from individuals to the whole colony. These signals can go for a very short distance, just from bee to bee, or a very long distance from one bee to the whole colony, from the whole colony to bees that are some distance away. These signals can also persist for a very short time or for a very long duration. So they can affect very long-term changes in the colony behavior, the development of individuals, and it really helps to organize the colony and just regulate all of their complex activities and the social structure within that colony. So they can elicit very quick, immediate responses to danger and things like that. We're probably all familiar with that pheromone. They can also induce physiological activity. So changes in individual bees and development into queens, or it affects laying workers and preventing laying workers and things like that. So in colony members, and also it can have effects in other species. So when we think about pheromones, a lot of times we think about odors, but not all pheromones are airborne. A lot of them are, but some of them are also spread from bee to bee in the bee's diet. They pick them up by touch. They detect them on surfaces using their antennae. So pheromones are chemicals that are secreted to the outside of an animal, and that elicits some kind of response in the same species. Some examples of these would be queen substance. We know that queen pheromones are important. We'll talk about those a little bit more. An alarm pheromone, we know about that. And Nasanov pheromone. We have different names for them. We call them odors and scents and substances and signals and things. There's also the same type of chemicals can also be classified as chiromones. These are chemicals that are secreted by an animal, but it's detected by another animal of a different species, and it tends to favor the receiver of that signal. An example of that would be the way that varroa mites can recognize a suitable host. So a varroa mite knows how old a bee is by the odor of the pheromones, or the odor coming off of her body. Basically, we call them cuticular volatiles, so volatile chemicals coming off her cuticle or her exoskeleton. That varroa mite recognizes how old a bee is and knows that it wants to be on a nurse bee of a certain age, so that it can find that brood that is just about ready to be capped off, and can recognize that odor as well. Bees also can recognize mite-infested pupae. So this is the key to things like hygienic behavior, where bees uncap cells that have reproducing mites, remove the pupa, interrupt that reproduction, and lower the overall reproduction of those mites. We can also talk about allomones. So these are chemical signals that create a change in another individual's behavior. It's favorable to the creature that emits it, but not the one that receives it. So these are kind of your con artist pheromones. These are what a laying worker would do. They produce kind of a quasi-queen pheromone, so that they're treated sort of like a queen, but they're not really a queen. Your Cape honeybee, that's only found in far South Africa, it can change its odors, and it can move into a hive and basically take over, and it creates clones of itself, but it's not a queen. It doesn't lay more workers. It just creates more pseudo queens because it produces a queen-like scent, and the other bees take care of them, which usually leads to the downfall of that colony when they get into another honeybee's hive. Pheromones are involved in just about every aspect of honeybees' daily life. All these different signals going around, all these different feedback loops, and the bees are all doing these jobs constantly. They're feeding information back into the system that helps it to regulate and to maintain all of these different activities. And pheromones involve messages going both ways. So some of them are called primers, and these act on physiological level. They trigger very complex long-term reactions within the bee colony. So things like queen rearing and the inhibition of laying workers stimulates bees to build comb. It initiates guarding behavior and foraging. So these are complex long-term reactions and developmental changes. And most of these that we associate with the queen and brood pheromones fall under this category. Releaser pheromones are generally a weaker effect, but they happen really quickly and they trigger real short-term behavioral responses. So this includes most of our worker pheromones and some of our queen pheromones. Queen pheromones are probably one that we're the most familiar with, just from the little knowledge we may have about that deep bee biology. So the presence of the queen's pheromone is the main regulatory factor that it kind of controls and structures the whole hive and determines that all those bees basically keep doing what they're supposed to be doing. But there's not one queen pheromone. She makes multiple pheromones. They're produced from multiple glands on different parts of her body, but they all work together. So there's no one single queen pheromone or queen substance. And each queen also has a unique scent, a proprietary blend, if you will, a signature recipe that makes her smell differently from all other queen bees. And this is how the bees can tell the difference between their queen and foreign queen. And of course, her scent also pervades the entire colony and gives every bee in the colony kind of a unique standardized odor, so that if a bee tries to enter the wrong colony, the guard bees can detect that. They can detect nest mates from non-nest mates, and they'll typically try to keep them out of the hive. Worker bees continually evaluate their queen, mostly based on the level of pheromones that she's producing. So as long as she's producing a lot, that's good. They're happy with their queen and they're going to take care of her. They're going to feed her. But over time, she starts to produce fewer pheromones, less volume of pheromones. So she's going to be judged to be a poor quality queen. And at some point, it tips the scales and it kind of induces that reaction to supersede her. Of course, in the absence of a queen altogether, then the workers have to act very fast. So they have to quickly rear emergency queen cells from whatever brood is available. If they don't do it right away, within a few days, of course, all the larvae in the hive are going to be too old to be turned into a queen, and they've lost that window of opportunity, and they'll be hopelessly queenless. And after about 2 weeks without a queen, without any brood, then that colony becomes pretty hopeless. You have a great increase in laying workers. So when queens are old, they're sick, they start to fail for whatever reason, there's reduced queen substance. And of course, when she dies, there's a complete absence of queen substance. And in both cases, queen rearing within hours is initiated. So bees can detect that loss or lowering of queen cell very quickly. Every single bee in the whole colony requires a dose of queen pheromones on a regular basis. So when the queen substance and the young brood are both gone, then that's when we see those laying workers. This results in an increase in drones and a decrease in workers as they die out of old age. And the whole colony just kind of starts to lose its structure. Becomes disorganized and dirty. The food stores get depleted. And then it's more susceptible to pests and pathogens, predators, robbing bees, all kinds of things. Here where I live, if it goes queenless for too long, the hive beetles will take over in practically no time at all. That queen's pheromones also are what make her so attractive, like this bee here, this good-looking queen here. So she becomes very attractive to workers. They form a retinue around her that feed her and groom her and take care of her and cheer her on. But she's also attractive to drones. And it's different inside and outside the hive, and it's different whether she's been mated or unmated. But when she's about 6 days old, 6 days out of the cell, then she's going to become attractive to drones on mating flights. She does not attract drones in the hive, and nobody's really sure why, but I think it's probably a function of concentration. You know, there's in the hive, there's so much queen pheromone there that the drones don't like that. It's as if you're sitting next to someone who's wearing way too much perfume or way too much cologne. A little bit might be nice, but a whole lot goes a little too far. So it's probably the same with this pheromone. But once she's outside and she approaches a drone congregation area, then she will be very attractive to any drones that are near her. And the same pheromone also helps to keep swarms cohesive. There's other pheromones going on there, but without a queen pheromone present, if a swarm settles in a clump and there's no queen, then they will disband and return back to the hive usually. This queen pheromone is also what allows you to impress your friends and neighbors and wear a bee beard. So typically a queen bee is put into a cage and you put that on a string or something under your chin, and they dump out a bunch of worker bees, and they're attracted immediately to that queen scent. And so they will nest all over a person and typically cover the queen cage and spread out and kind of form somewhat of a beard. There's other tricks to that gimmick. Sometimes you can take a hive and move it away and put an empty hive there. And then all of the bees, all the older foragers will leave and come back to an empty hive. And that leaves the hive with the queen having only young nurse bees, which are much less likely to sting, and they have much less bee venom stored in their sting glands anyway. So those are the ones that you take and you can dump out and impress your friends with. So still no guarantee you won't get stung, but it really lowers the possibility. These workers are outside their hive. They don't have any brood or food to defend, and so they're not quite as likely to sting. Among the queen's pheromones, there's a number of different components, and one of the most important ones we call queen mandibular pheromone, often just abbreviated QMP. And it's not one chemical, it's a very diverse compound, and it's got at least 18 components we know of. There may be some more, but the most important ones are these here that have really long names. And the 9-ODA and 9-HDA are some of the most important ones there. There's other compounds that are produced in different parts of the queen's body that aren't terribly active by themselves, but together with the QMP, they greatly enhance the action of QMP. So it works by itself, but when the other pheromones are present, this stuff works even better. As a queen bee ages, the composition of this mandibular pheromone actually changes over time. And so it elicits various responses from other bees at different times. So as I mentioned, the newly emerged queens being attracted, drones are attracted to. The workers actually approach and interact with the queen differently when she's brand new and virgin queen, and when she's on her mating flights or getting ready to mate. And also after she returns from a mating flight, the bees treat her differently as well. So this is produced by glands that are inside the head, just above the mandibles. That's why it's called mandibular pheromone. And these open into a channel. It's kind of a duct down to the base of the mandible. And then there's a groove or a channel that's surrounded by hairs that it kind of leaks into. And this increases the surface area as it flows off into all these different little hairs. So this secretion is then picked up by worker bees when they are feeding the queen bee. They are picking up a lot of this pheromone from her. And then, of course, bees constantly share food with each other. So they pass it on through trophallaxis to other bees, and those bees pass it on to other bees and to other bees. And the queen herself actually receives her own mandibular pheromone when she's fed by her worker bees. So she gives off this pheromone when she's being fed, but she also has to consume some back in the royal jelly that is fed to her. And this actually functions to regulate some aspects of queen rearing. When the queen is fed a lot of her own pheromone, then it inhibits swarming and it inhibits supersedure. So you may hear that young queens swarm less and old queens are more likely to swarm. Part of that is the amount of pheromone that she's producing, but it also has to do with the population of bees in the hive. So when that level gets really low, such as an old queen or an injured queen, then that's when it induces supersedure. But when we have a very large population of honeybees, then each individual worker and the queen herself starts to receive less of that mandibular pheromone on a per capita basis. And that's what actually initiates that swarming behavior. If you consider a pizza, not a bad meal for one or two people, and everybody can get a slice or two, but then you have a couple more people come over. Well, that's no problem, we'll just cut it again, and then everybody maybe gets one slice, still a decent snack, but more people arrive at the party, we slice it into smaller and smaller bits until everybody just gets a thin sliver of pizza, just enough to taste it, and you're still hungry. So you don't have enough pizza. So it's kind of the same way with the queen pheromone. As the population of bees gets bigger and bigger and bigger, the queen can only produce so much pheromone at a time. So each bee is getting less pheromone per day. And so when the queen doesn't get enough pheromone, that triggers her to go and seek out queen cups. So queen cups are those shallow vertical cells usually found on the bottom edges of combs. Anywhere a comb has been damaged and rebuilt by the bees, sometimes you'll see these. But anytime a worker bee finds an egg or a larva in a vertical orientation, facing down and instead of out horizontally, it's hanging down, then they will provision that cell with a lot of extra food, a lot of extra royal jelly. So these worker bees don't initiate swarming, but as soon as they find these swarm cells, these queen cells, then they feed them up. And so they rear those swarm queens out. Lots of mandibular pheromone inhibits the workers from starting queen rearing, though, because the queen, when she's receiving a lot of that, she assumes that the population is not big enough to need to swarm, and she's going to go ahead and continue laying eggs and not look for those cells. Of course, if she runs out of room, she doesn't have any place to lay eggs, she will also initiate swarming by laying eggs in those queen cups as well. So it's not just the pheromones, there's more to it than that. So this mandibular pheromone inhibits workers from starting queen rearing, but it does not stop them from caring for developing queens. So this is how you can rear queens in large numbers. You can graft a larva or use some other method to introduce the larva to a colony that is in a queenless state. And as long as we turn those cells facing down, then they'll try to rear them all out. As long as they have resources, they'll try to feed them all, and you can raise hundreds of queens at a time. Another function of the mandibular pheromone is to suppress worker reproduction. Your worker bees sometimes lay eggs. They don't normally, but every once in a while you'll see it happen. They do have ovaries, but they remain underdeveloped in the presence of the queen, a good laying queen. And part of this is queen mandibular pheromone, but there's some other signals going on there as well. But in the absence of mandibular pheromone, the ovaries of a worker bee can become active. They have fewer ovarioles, so the cells that generate eggs and mature eggs, they have fewer of those than a mature queen, but they can still function. And of course, your worker bees, if they do start laying eggs, they only lay unfertilized eggs. They don't mate, they're not inclined to, they can't, and so they lay unfertilized eggs, which of course become drones. And so you may see multiple eggs per cell. That's a good sign of laying workers, although sometimes it's a sign of a brand new queen who hasn't quite got the hang of laying eggs yet. Sometimes she'll drop 2 or 3 in a cell, but usually within a week she understands her business and she'll stop doing that. If you ever see multiple larvae in in a cell, then that's usually a sure sign of laying workers as well. They usually call that out pretty quickly, but sometimes they'll do that. And of course, if you start to see worker-sized cells with these drone cappings sticking out, that's usually a sign that you've got laying workers too. The mandibular pheromone usually functions with other pheromones to suppress that worker reproduction. So just the presence of individual brood larvae, they give off their own pheromones, which I'll talk about in a minute. And this is probably even more important than mandibular pheromone for suppressing worker reproduction. That mandibular pheromone is really just one component of the overall queen substance that are produced in a bunch of different places in the queen's body. Another important location are the tergal glands. So tergites are the exoskeletal plates on the back, you could say, of the bee's abdomen. On the lower surface of the abdomen, they're called sternites, but on the upper surface or the rear surface, then the dorsal surface, they're called tergites. So we've got Greek and Latin names for every part of the bee. And if you watch bees tending to their queen, of course, some bees are feeding the queen, but there's a lot of bees that are touching the queen's abdomen with their antenna. So they're picking up a lot of that pheromone, they're detecting that it's there, and a lot of them are also licking the queen. And there's much more of this activity associated with mated queens than unmated queens. So this suggests that there's a pheromone signal that workers can tell that the queen has been mated. And this pheromone is produced much more prominently in a naturally mated queen than in an artificially inseminated queen. So it's still there, but not to the same extent. So that means that somehow the bees know whether that queen has been naturally mated or not. About 10% of the bees in a retinue tend to be lickers, the ones that are actively licking the queen's abdomen. But this small proportion of the bees tend to pick up about 50% of these important pheromones. And then they seem to ingest a lot of what they receive. And we're not sure why. They pass on a lot more, but they actually ingest a whole lot of it. And this may act as a hormone once it's ingested and make these bees particularly loyal to the queen and taking care of her for a little while. Another place that the queen has pheromones are on her tarsal glands. We call this footprint pheromone. It's secreted from the tarsomeres, the little pieces of the foot. So if you've ever looked at the bottom of a bee's leg, you see how there's a very flexible area right before you get to the little claws and the sticky pads there. So as a queen bee walks around, or any bee, this footprint gland is actually present in queens, workers, and drones, but it's deposited on the comb as she walks around. And this pheromone seems to be specific for each caste, and the bees react to them in different ways. So it's kind of a colorless, oily secretion that is deposited on the comb as the queen walks around, and it tends to inhibit queen cell construction in that area where the queen has been very active. So when you see bees that are building supersedure cells, usually they try to do this away from where the queen has really been working. They wait until she's not looking, I guess, before they rear her replacement. This one works really well with the mandibular pheromone. It's not quite as active on its own. And as the queen ages, then this signal starts to diminish a little bit. So this may be part of how the bees determine that their mother is getting a little bit old. So not quite so much of that pheromone. Another one that the queen produces is called the Dufour's gland pheromone. This is associated with her egg-laying equipment. It's associated with the sting apparatus. Basically, in worker bees, it would be part of the sting apparatus. But with the queen, it's secreted around the sting sheath, So queens do have a stinger or an ovipositor, and so it opens up into that channel where the eggs slide down. This is a very caste-specific egg marking pheromone. We think it's related to egg marking and reproduction by the queen, so that when worker bees begin laying eggs, laying workers don't produce the same pheromone as queens, and so worker bees can detect whether an egg has been laid by a queen or if it was laid by another worker. And a lot of eggs that are produced by laying workers are actually removed by other workers. This is called worker policing, and they'll actually chew up and consume those eggs sometimes in order to conserve the protein. But this is important for keeping laying workers down in the hive. And queens will also sometimes remove eggs she finds that she realizes she has not created. This one is important in attracting the retinue to the queen as well. It doesn't work all by itself, but it works with the mandibular pheromone, and it has a similar but weaker effect in laying workers. So it tends to attract some bees to laying workers that will kind of start to treat them a little bit more like queens. So laying workers start to produce sort of a pseudo queen pheromone from this gland as well. But in general, it relays to the colony that it's queen right and it's healthy. And as I mentioned, it works with the queen mandibular pheromone, and it helps to prevent worker ovary development. Now, virgin queens have a specific pheromone that is associated with their feces, and it's only found in virgin queens. It begins to be produced when they're about 24 hours old, and it lasts for about 2 weeks. So this is the period when these young queens may have some hostile encounters with other queens. There may be some queen fighting, or sometimes with worker bees. They may have some hostile encounters with them. And so they actually will turn around and discharge their feces at the other bees, and this will repel the other workers, which of course is pretty logical. I think if somebody was doing that to me, I would be pretty much repelled. And it induces an auto-grooming behavior in the other bees. So that's also very understandable. If somebody did that, you'd want to go wash up, right? And in bees, it reduces aggression. I don't know, it might make me more aggressive, but from a distance, I don't know. So they do this particularly when they are fighting off rival queens. So they keep their distance from each other. Also within the bee, the queen bees are something called a Koshevnikov gland, which is one I always mispronounce. I'm not even sure if I got that right, but it's also associated with the egg-laying machinery in the bee's abdomen. So there's a composition and a function of this. It's found in both queens and workers, but it's very caste specific. So in queens, it's part of that overall queen scent blend. It helps to give the queen her identity, but it starts to degenerate after the queen is about a year old. And so this probably also contributes to that loss of signals in older queens and promotes the supersedure of older queens. In worker bees, however, this same gland produces isopenyl acetate, which is alarm pheromone. This is the pheromone that we say smells a little bit like bananas or banana peels. So when a honeybee identifies an intruder or some danger and tries to sting it, then some of that pheromone is released, and this actually attracts other bees, and it provokes them to become much more stingy, you could say. But this also marks you, beekeeper, as an intruder, as a danger. So if your bees don't like what you're doing and you get stung, then if you don't get your hand out of the hive immediately and get that stinger off and puff a little bit of smoke over that sting, don't be surprised if you get stung on that same spot again and again, because that one spot is going to attract more bees that will associate your hand with some bit of danger. So alarm pheromone is one that unfortunately we probably know quite a bit about if we've been keeping bees quite some time. It's released when bees feel threatened. It excites other bees. It alarms them to let them know that there's danger. Bees that are guard bees are particularly adept at giving this off and sensing it, but it tags intruders as a specific threat. So think about robbing bees. If you've ever seen bees grappling with each other on the landing board of a hive, and they're trying to repel one, and it's not going to listen, then of course they will sting it to death, and they'll literally tear it limb from limb as an example to the others. They can't let it get inside the hive and then get away. This isopenyl acetate is a very volatile molecule. It's small and lightweight, and so it spreads very rapidly into the air in all directions. So this is a very fast-acting pheromone that can go quite far away from its source. And so this is exactly what you would want in an alarm situation. If there's danger to the hive, the colony wants every bee to know it, and they want every bee to know it right away, and they want to call more bees into action. It also dissipates very quickly. So once the danger is over and bees stop emitting this alarm pheromone, then it dissipates out of the air. That doesn't mean that the bees are necessarily going to calm down instantly, but it will disappear on the breeze pretty quickly. The bees may stay on high alert. This is part of what makes Africanized bees such a danger, because they release a lot more of this pheromone at one time. It takes much less to trigger the reaction to give off this pheromone, and they stay in a bad mood much longer than European bees. There's another alarm pheromone called 2-heptanone, and it's actually associated with the mandibular gland. So it's a mandibular alarm pheromone, and it is released when bees bite. So particularly when they identify another individual as a robber bee or an intruder, they bite them first rather than stinging them, and this helps to tag that bee as a danger, as an intruder, and other bees will try to bar it from getting into the hive. So it's kind of a non-lethal way to send another bee packing, but if they don't listen, then they're probably going to get the stinger after that. This pheromone, this mandibular alarm pheromone, also works on varroa mites. Studies show that it anesthetizes or paralyzes varroa mites when they're bitten. And it may do the same for wax moths and other things, but it's probably a lot easier to remove and get rid of a varroa mite if it's been rendered paralyzed. So that's an interesting action that it has on another species. Smoke, of course, is not a pheromone that is produced by the bees, but you could say that it is a real success story in as far as our relationship to the honeybee and our understanding of bee behavior. Of course, for centuries, people didn't know what smoke did specifically on a physiological level, but we knew that when you smoked a beehive, it tended to keep them much more calm and easy to work with, or easier to rob for honey. The traditional logic was that honeybees are forest species. They live in trees, and so when they smell smoke, they must think it's a forest fire, so they'll gorge themselves on honey, and then they're too fat to bend over and sting you. And there is a little bit of truth to that. If you over smoke your bees, they will gorge themselves on honey, but you really don't want to do that. You don't want to cause your bees that much panic where they tear open all the capped honey and slurp it all down, because then they'll have to repair all that later. A little bit goes a long ways. That middle picture there on the bottom, this is one of our normal size smokers. This is a South American Africanized bee smoker. So if you were working bees in South America, you'd have one person whose sole job is just to pump smoke really fast the entire time you're working on those bees. So they're it still works, but you know, you want to use a lot more. Of course, this top left image here, we've probably all seen that one in various books. That's one of the oldest depictions of beekeeping from a cave painting in Spain that supposedly shows a person on the side of a cliff stealing honey from a wild bee's nest with all the bees buzzing around them. And this is the honey hunters of Nepal here, where they just are swinging a big load of smoking branches and leaves while they try to knock those bees nests off of a cliff. So, you know, it's a lot easier when we keep the bees down at ground level and we can use a little bit of smoke. Foragers give off a pheromone themselves. It's called ethyl oleate. We don't really have a fancy name for it, but it's released by older foraging bees, and it functions to slow the maturation of nurse bees. It helps to regulate the structure of the colony in terms of the age of bees, their physiological age, and the tasks that they do. So it maintains an optimum ratio of nurse bees to forager bees to meet the colony's needs. If say in the summertime when there is a big dearth and they don't need very many foragers, then it functions to the presence of lots of foragers keeps a lot of other bees kind of in a younger physiological state, sort of keeps them in reserve for a while. And that way they stay healthier, they're in less danger, and the older bees will still go out and forage, and there's plenty of them to find the few flowers that are there. If there was a sudden nectar flow, then a lot more bees would be out of the hive, and more of these bees would be maturing and moving up into that role. Likewise, if there was a sudden absence of older bees, then that can induce precocious foraging. So if you have a pesticide kill, for instance, and a large portion of your foraging force has been removed from the colony, then some of the younger bees will prematurely move into that foraging role. In an absence of nurse bees, then that causes regression by the older workers back into that younger bee jobs, so they can take over those jobs again. And you might see that situation after a swarm has left. About 2/3 of those bees tend to be younger bees. Some are older, but a swarm takes off with a lot of younger bees because they're going to be longer lived, and they'll need that when they are establishing another colony. So some of the older bees can regress back and care for the brood that's there. In case of a bee disease taking out a lot of the brood, you might see something similar. But in an ideal situation where everybody's healthy, then this pheromone helps to regulate that age task structure into what's ideal for the situation that the bees have. Another pheromone is Nasonov scent. This is one that we may be familiar with. It's put out by the Nasonov gland. That's that little pale band that is right between the 6th and 7th tergite. And we see bees sometimes with their heads down at the entrance of the hive, and their abdomen is in the air. They're vigorously fanning their wings. And what this is doing is it's creating a plume of pheromone from the source here at this individual bee at the hive entrance off into the air. And it's a signal to other bees that are out that may be lost, not sure where they are, that this is home, this is where the queen is, this is where the hive is. So when you install package bees, for instance, or you hive a swarm of bees, you'll see a lot of this behavior going on because you've shaken a lot of bees out that are not sure where they are, and a lot of them are in the air. And the same thing happens when you open a hive sometimes, and you may brush off or shake off a lot of young bees that have never been out of the hive very much. They kind of fly around at random, and then when they encounter this Nasonov pheromone, then they can follow it down upwind to its source, which is, of course, the back end of another bee at the hive entrance, and they can walk right into safety. So it helps to attract lost and disoriented bees into a hive. If you are installing package bees and you have 10 empty hives and 10 packages and you dump them all in one after another, sometimes you may notice that one hive ends up being much stronger than another, or one hive maybe gets weaker. That's because this Nasanov scent is pretty much universal, and whichever hive entrance is pumping out the most is going to attract the most bees that are lost and disoriented. Or it could be that the wind is blowing from one direction, and so lost bees are going to follow that upwind to the source of pheromone that they can find. You may be familiar with some of the swarm scents that you can buy, the artificial scents, and a lot of them contain lemongrass oil. This is, or geranol is the main component of that. But this mimics that natural Nasanov scent, and you can put a little bit of this into an empty hive or a swarm trap, and it helps to attract those swarming bees over to it. It attracts scout bees over to it to check it out and bring the rest of the swarm back in there. So it helps to maintain a cohesive swarm when they're resting together. And of course that works with the queen pheromone, but it also works with a swarm of bees when it's in flight. You know, that's a huge cloud of bees that looks chaotic. They're swirling around in all directions, but it's actually highly organized by this Nasanov pheromone. So when that cloud of bees is on the move, there may be a few hundred bees that have actually been to their new home. Could be a hollow tree a mile away, 40 feet up in a hollow tree, and it's got an opening the size of a quarter. But every one of those bees is going to make it there in 10 minutes, because that relatively minor number of scout bees, individuals will zip through that cloud of bees, pumping out lots of this pheromone. And as they get to the front of the swarm, they slow down and they go around to the side. As the swarm moves forward, they wind up in the back, and then they'll zip through it again. And so you have this constant movement of bees through the middle. And each time they go forward, they go a little bit farther and a little bit closer to their final destination. And it functions to bring all the rest of those bees following this trail of pheromone through the air. And that's how a swarm can get from point A to point B in just a few minutes. That seems unimaginable to us how that could happen, but it all comes down to this Nasanov pheromone. This scent is also used to recruit foragers to a water source. A lot of times water doesn't have a characteristic scent. Sometimes food may not have a characteristic scent, so it also helps to bring them there. Sometimes things like your neighbor's hummingbird feeders, that are just full of sugar water. But if you may notice a creek, it goes on for a long distance, but you see bees always go to the same spot to gather water, because the first couple of bees that found it, they gave off a little scent to help other bees find it. And so they all keep coming back to this one little spot, even though they could go anywhere along that creek. And when a queen bee, a virgin queen, is ready to leave the hive, then the workers will sometimes gather near the entrance, and you can almost hear them saying, come on, sis, it's time for you to do your job. And they kind of escort her to the entrance, and they'll give off a lot of this pheromone as she leaves on her mating flights that helps her to orient on that spot and to be able to return to that spot a little while later. So it helps the success of the queen on her mating flights when they have this pheromone to help orient on. I mentioned footprint pheromones earlier, and how they're used with the queen, but they're also used by the worker bees. So as the bees go in and out of their hive all day, every day, then a lot of this pheromone builds up near the entrance. So in a forest, all the trees look the same. There's that one little knot hole where bees may be going in and out. Then this helps the bees kind of zero in on that one spot. As they approach, they can smell their landing area. So it's kind of creates a bullseye around the entrance of their hive. It's also thought that it will help to mark flowers that have been visited by bees. If you ever watch honeybees working a patch of clover or something else that has a lot of little tiny flowers on it, like this lavender, then they don't land and investigate every flower. They kind of fly around and they look and they'll skip over a few, and then they'll land, and of course they have to stop and probe each flower with their tongue to get the nectar. And so it's thought that they can detect from this footprint pheromone that another bee has been on that flower recently. So it makes them more efficient. Rather than having to stop and visit every single blossom, they can skip over the ones that they detect have been visited recently. There's also some evidence that bees build up an electric charge as their wings flap, and flowers also have an electrical field. And once bees have visited a flower, it may somehow change that electrical field in ways that we can't really detect. But there's some people that are trying to investigate that too. And of course, your drones don't want to be left out. They also have a few pheromones of their own. Drones have a mandibular pheromone. Their glands are much smaller than that of workers or queens, and it's not entirely known what that's for, but it's believed that it helps to attract other drones to a drone congregation area, just help them to kind of stay together in a discrete location, and also helps to orient virgin queens. Once they approach that drone congregation area, then they can zero in on that as well. It's just the concentration of drones in one spot helps to amplify that signal. There's more to that as well, but drones also have those tarsal glands that produce pheromones. Its specific function is not yet understood. It probably has to do with the ability of the workers to find them and get rid of them when it comes time to eject them in the fall. But it may just be a function of bees having feet, but there's probably some other signals going on there that we don't fully understand. And drones probably have other pheromones that determine whether they can enter a hive or not. Drones tend to drift quite a bit, so workers understand that they're drones. Even if they smell like a foreign queen, they're often allowed to come in and out of different hives. But drones are really poorly understood compared to queens, especially, and of course worker bees. But their importance is being recognized more widely now as part of overall bee health and what we need to know about bees. So people are studying them a little bit more. Individual larvae also give off pheromones. So each brood has a different odor depending on its age and its caste. And nurse bees can tell how old a bee is, whether it's male or female, whether it's a worker or destined to be a queen, just by walking up and putting her antenna over the edge of that cell. So this is one of those pheromones that goes a very short distance because otherwise it would overwhelm the entire hive. So it's a weak signal, but the bees have a very sensitive antenna. And so they can detect that just by dropping their antenna in there. They know what to feed that larva, how much, and they can also detect the odor that tells the nurses it's time to begin capping that cell, that larva is ready to pupate. These are the same signals that attract parasitic mites to their hosts. So the mites can detect that this is a nurse bee that is going to be tending to the oldest larvae, and it also are able to tell that this mite knows it wants to be on this bee because this bee will be over these particular larvae. And when it finds a larval cell that smells just right, that's given that signal that says, I can't possibly eat another bite, go ahead and cap me, I'm ready to spin a cocoon, then that mite will disappear down into that cell. And of course, we mentioned hygienic bees. They also detect mites. So that's something we're trying to breed into honeybees now, that those bees will be able to open up those cells and be able to detect those mites and to get rid of them, and slow down the success of those mites. So there's probably a lot of other pheromones that we don't quite understand. Well, maybe not a lot, but a number of them. Pheromones are something that we have been trying to understand. We've been trying to interpret for a long time, and people have also been trying to speak the language of pheromones. You can buy artificial queen pheromones. You can drop them into queenless hives, and you can use those to kind of hold a hive and prevent laying workers for a while. They have experimented with the different pheromones to spray onto the flowers in orchards to attract bees to the flowers. And there's been some success with that, but again, not a whole lot, because we might know some vocabulary of this bee language, but we really don't understand the grammar very well at all. Sometimes people like to get tattoos of Chinese characters, and they might go to a tattoo shop and say they want, peace and love on their arm. And then years later, they have a Chinese friend that says, "Why does your arm say sweet and sour sauce?" They looked at something, they thought it was cool. They didn't bother to look it up more carefully. They just thought it looked pretty. And the tattoo artist said, "Okay, I'll draw that." So it's kind of the same way with the pheromones, but that's what I came to tell you guys about bee pheromones. So I don't know if you guys have any questions, but
yeah. So John, I have a couple of questions in the chat that we'll go over, but so the last time I checked, I didn't see a nose on a bee. So can you talk a little bit about how bees actually can detect these pheromones? What body part are they using? How do they do that?
That's a great question. No, bees do not have noses. No insects do, but they use their antennae to detect odors. And that's why I started talking about electroantennograms early on in the slideshow. So their antennae are covered with microsensory cells that are very receptive to airborne odors, as well as contact with surfaces. So bees are much better at sniffing than we are. They're better than the best bloodhounds. Honeybees are amazingly acute to odors. In fact, the Defense Department has been experimenting with honeybees to sniff out explosives and checkpoints. They can find landmines buried in the ground. You can train bees to associate gunpowder and explosives with food, and then you let them go and they'll settle in an area where something is hidden. They can also strap honeybees into little machines with cameras, and you can program a bee to associate an odor with food, and they exhibit what's called a proboscis extension response. Basically, they stick their tongue out, kind of like you can train a dog to salivate when it hears a bell because you feed it. You can do the same thing with bees, and they have created computer programs that will monitor a bee's tongue. And there's a really neat video on YouTube you can find if you're interested in that. But yeah, antennae, that's what it's all about.
Okay. And Joe asked, how long does the worker pheromone how long is it left on a blossom? Is there any indication, she's for proper pollination, some blossoms require multiple visits. And I think, her question stems around if a bee is avoiding a blossom because it's already been visited by another bee, how long does that pheromone last? Is there any science on that?
I don't know the exact science on that, the exact numbers. I would imagine that it lasts a little while, but basically flowers, they produce nectar at certain times, and depending on the weather and the moisture, and so they can actually kind of recharge with nectar. So Probably within, I would just guess, I don't know for sure, but I would say within a day or two that pheromone would probably dissipate.
Okay. And an interesting question from Becky: if swarming is triggered by a reduction of QMP, can artificial queen pheromone be placed in a hive to reduce the urge to swarm?
Yes, probably so. Again, we're playing with a language we don't fully understand. So, that would be like me talk pretty. We're using very, very basic grammar there, but it's also a function of other things in the hive, how much space there is, for the queen to lay eggs and things like that. But assuming she's got plenty of space, you could probably extend that to prevent swarming, or at least buy yourself some time.
Yeah.
But if you're aware that your hive wants to swarm, there's probably better ways to approach the situation than to put in an artificial swarm lure or preventative. You could split that colony, or you could requeen it, or you could give them more room. So if you're aware of the situation, then there's other ways you could mediate that.
Great. And then Lil A, she asked, is the queen's scent unique? Is queen's unique scent genetic, or is it because of what she is fed?
There's probably a little bit of both. I'm sure that her diet does affect her overall odor, but there's probably a genetic component to that. Otherwise, the queen scent would be changing constantly, because most flowers are only in bloom for a week or two before they're replaced by something else. And so that queen's odor would be changing all the time. So I would imagine that it's probably going to be more genetic.
Okay.
Good question, though.
Yeah. And then Marcia asked, and I think you did touch, and this is something I didn't know, so this was new for me, that she, did she understand correctly that the queen senses, through the feedback loop, that she's not producing as much QMP, and that is one of the triggers for her to lay an egg in a queen cup? That's an interesting.
Yeah, it's not that she senses she's not producing it, it's she senses she's not getting enough. It gets back to that colony population. So if you have an older queen who may be producing less pheromone, but she's also laying fewer eggs, she may not swarm. But if she's producing less pheromone and still producing lots of eggs, she's going to have more of a tendency to swarm, because she's receiving less pheromone. If you split a colony and suddenly the population is reduced, then she may not be so inclined to swarm, because now she's receiving much more of her own pheromone, at least temporarily.
Okay. The question is, one more question. The queen retinue, is there an age of bees that tend to form that queen retinue that then, transfer that around in the hive? Has there been any studies on that? I'm just curious.
I think there is. It's typically younger bees, because your younger bees have the well-developed hypopharyngeal glands that produce the royal jelly. So they're the ones that are feeding the youngest larvae, and as well as the queen. And as the workers begin to age and they start doing different jobs, then their physiology changes, their hypopharyngeal glands shrink as they get into nectar workers and things like that. But you have other young bees that age into that pretty quickly. So that retinue is one of those jobs that's constantly being replaced. Every few days they're moving on to different jobs. So that one is pretty much restricted to young bees.
Okay, good. Anybody else have any questions? Great talk. I find, queen pheromones fascinating. Anybody else have any questions? Is there any takeaways, John, for like the backyard beekeeper when it comes to pheromones? I know, it's maybe a lot of information that, most backyard beekeepers.
Yeah, that is a lot of information. And for the most part, it's nothing you have to know to be able to keep bees. People people kept beehives for thousands of years without knowing all of that. But the more you understand about your bees and their biology and what's going on and kind of what makes them tick and how they interact, then sometimes you can look at a situation and puzzle things out and think, oh, that makes a little more sense now.
Good. All right. Any other questions from anybody? I think we kept people very engaged. All right. Thank you, Dr. John. Appreciate it. Look forward to hearing you again this year at EAS. I'll be traveling.
I will be there in a couple of weeks.
Yep.
You mentioned something about somebody had a pesticide kill in your area.
Yeah. So, and I don't know, Robert, Cheryl, do you want to, who wants to jump in and maybe open up a little bit of a discussion? Maybe Jim Kelly, I know you're on.
Michelle had a Zoom meeting at 8 o'clock, so she's not currently on. She had 3 colonies. She lives about 1.25 miles west of me. And she started to see dead bees outside all 3 of her hives, increasing in number starting several days ago, and brought it to my attention this morning. So I went down to visit her colonies and told her to go ahead and file a pesticide complaint with the state of Kansas. And they called within an hour of her filing the complaint online. And she spoke with Ken, and he came out and visited the hives here at noon today and had her sample some bees. And then he took those with him. That's about all I know.
Can you share a picture? You or Robert, can one of you share a picture? I believe
Robert might be able to share a picture. She's had an accumulation of dead bees. They've continued. Her strongest hive obviously has the one with the biggest pile of bees out in front of it. They're still carrying out dead bees. They look like they've gotten into something. I asked her about water sources with the heat, how it is. I asked her about, we had spray applicators by helicopter, but that was 6 days ago. I'm not sure what they were, what chemicals they were spraying. I didn't notice any kills in any of mine or increased dead bees outside the hive after the spraying. I did notice as I drove over to her house this morning that she had a neighbor across the street, a couple doors down. We all live on, 3 to 5 acre lots out in a rural setting. And I noticed her neighbor had a sign out front that they had received mosquito treatment here recently. They use their advertising little shingle out front. They service both the Topeka and Lawrence areas. So I suggested that maybe she should contact the neighbor and see when the application of mosquito treatment was put on their property. Perhaps they had a gathering over the weekend and they thought it was prudent to apply that prior to their gathering. And I know we've had some alerts in the state of Kansas in regards to West Nile virus being at a higher level. And so my concern to the group is that we may see more of this as people try to think they're doing the right thing and applying either, they sell these products as the chrysanthemum or organic spray versus the other, and lead the consumer to think that they're going to affect the pollinators less if they use this other treatment versus the other. I mean, obviously her hives are in full view. They're out in the front yard. You can see them as you go by. So it would not be an issue of the neighbor didn't know she had beehives, or even the applicator not knowing she had beehives. They're in full array. They're marked boards like that. You could see them from the street. So that's my concern. You know, I don't know if it was the mosquito application that did this. We probably never will know, but I just wanted to put it out there for the group. And, you know, if you see something like this, you need to report it. The state is not going to know that we're having kills unless, you know, we come forward and
Cheryl, who do we report that to? Who do they call?
There's Robert, do you have the link that I sent you earlier? It's through the state of Kansas. It's kansas.gov, and then you go to pesticides, and is it fertilizer and pesticide?
Correct.
Pull it up here.
It's also in the cappings.
Yeah, well, I know, yeah, but not everybody subscribes to the Kansas Honey Producers cappings. I mean, you could get it through the archived. But yeah, I pulled it up for her today, and I had her go ahead and file a complaint so they could come out and do an investigation. It's right on their front page under pesticide and fertilizer program, kansas.gov or agriculture.ks.gov. And then it'll take you right. You can go to their pesticide fertilizer program, and it's the complaint forms right there. It's highlighted in yellow. And I would encourage you to, if you suspect you have a pesticide kill, to file a complaint. I was really impressed that they responded to her within the hour. So, and when she mentioned the mosquito applicator, he decided he was going to come out today. You know, I wish she probably should have reported it a few days earlier, but I don't think she realized what she was dealing with. So
if you do see a bee kill like that, it's prudent to take a sample of bees and put them in a jar and freeze them right away. Keep them as cold as you can, because things tend to degrade pretty rapidly in sunlight. So I don't know what your state does as far as toxicology. You can send them off to other labs, but it costs about $300 a sample to test for.
Like to Beltsville.
I don't know. Beltsville does not do chemicals.
They don't do it. Yeah,
but I have all mine done through the National Science Lab, and it runs about $300, maybe $350 per sample, so it can really add up. But another place to report suspected pesticide kills is to the EPA. There's an email address, beekill, all one word, beekill@epa.gov. And if nobody reports these, then they don't have the information, but they consider incident reports that they get to help them inform their regulatory decisions. So every report that they get helps them to identify patterns of bee kills associated with specific pesticides or active ingredients. So, you know, it's difficult for them to say we have to change the label or restrict the use of something if they don't have any data to back it up. So every report that they get helps. And, you know, a lot of people think it doesn't matter, the EPA is not going to do anything, but I've actually talked to some of the people at the EPA before, and there are people that care. They very rarely get anybody to report it. A lot of beekeepers are reluctant to report bee kills because they know that they may lose their bee yards on farmland if they cause a stink, and it's, you know, it's part of the risk we run as beekeepers. So they don't want to rock the boat. Another program is called Drift Watch, and a lot of states are signed up to that. And I see here that Kansas is. It's a voluntary program. You can register your hives through a program called Bee Check. Basically, you put your apiary locations onto a map. And in some states, pesticide applicators are required to check that map before they spray chemicals. And it it's not only for beehives, but it's also for organic agriculture and things that are sensitive to herbicides and pesticides and things like that. So it's a program called Drift Watch, Field Check, and Bee Check, and Kansas is part of that. So ks.driftwatch.org will take you to that, and you can set up a free account with them.
I believe Iowa registering part of that is part of their, I won't say it's not a requirement of the Beekeeper, but like as you indicated, the applicators, but it only applies, I think, to the commercial applicators, the licensed commercial applicators, the farmer that does his own spraying. I don't think they're quite held to the same standard that commercial applicators do. Are the labs able to determine what the chemical is then? And then, from that, for example, Cheryl said, there was, some aerial spraying occurring, and then there was also some mosquito, spraying going on. Are they able to determine, obviously not necessarily the source, but what the actual chemical is?
Well, we did a bunch of work here in agricultural areas, and we sampled bees and pollen and honey and beeswax, and the standard, the National Science Lab has a standardized test that looks at, I think, 157 common agricultural chemicals.
Okay.
There's some common things that aren't included in that because they have to run different tests for them, but they have a battery of tests, and they can get down to 1 part per billion on some of those. Others not quite that refined.
Interesting.
But again, it costs more to run one sample than it would be to replace 2 colonies.
This is Jim Kelly. I might add that for Kansas, when picking up that sample to put in the freezer, that breaks the chain of evidence for our investigators. So it's good for you to put that in there if you want to spend the money to have it tested. But the investigator has to either visually watch you pick up the sample and put it in, or pick it up himself and take it in. That's a chain of evidence thing for them. And our bee check here in Kansas is voluntary for both sides, unfortunately. So it is getting better. There are a lot more people checking it. That's including applicators. So as more people hear about it, it seems to get better. Also in the chrysanthemum that they were talking about, that's actually pyrethroid product. It's a spray kill on contact. Is what that comes from, but they call it organic because it's brought from the flower, but it's very deadly.
Yeah, thanks, Jim. That's good information. I think it only reinforces, Cheryl's comment that if you suspect that you have a pesticide kill, you need to reach out very, very quickly. It seems like they respond very quickly to collect that evidence.
It is nice. We ran into that in the 80s when it was really slow as far as coming out. Of course, we were in Western Kansas, so it might be a couple of days at 100-degree temperature, and the half-life of a lot of these chemicals, it would be disintegrated by the time they came out to take a sample, and they would show up with no chemicals found. So we had to kind of reinvent the wheel back then to make that come out better.
All right. So yeah, so everybody keep an eye on your hives. I know that the West Nile is becoming a problem in Kansas, so we might start seeing a lot of mosquito spraying. So I don't know if that'll have any sort of impact or not. All right, Robert, Ed, do we have anything else? Oh, Jolie, are you still on? So,
I am.
do you want to promote our KHPA meeting?
Yeah. So we've been doing these value-added third Thursday value-added presentations by Zoom. And this month's is going to be this Thursday at 7 p.m. Central on July 21st. And it's going to be taking care of your honey from hive to the bottle. And we'll talk about the best way to prepare your honey as you take it off the hive all the way through bottling it so you don't have foam. So you let it settle for a good 24 hours before you bottle. And we'll talk about preparing comb honey and chunk honey for sale. So that'll be this month. Next month on August 18th, we have lined up people from the state of Kansas to talk about labeling your products and to talk about when you need a certified kitchen and that sort of thing. And then I'm going to try and get Eugene, who's editor of American Bee Journal, to spend a few minutes talking about what Missouri has done with their cottage industry honey. Though Kansas has already done that, it's really not an issue for us, but we do get people from other states on. So anyway, that's the
Okay,
plan
thank
so
you,
far.
Shirley.
And then September, I want to give a shout out. We have, what's his name, Bob? Rich Whiskey from Michigan is going to talk to us about collecting pollen, preparing it for sale, and some different things to do with it. So that's the next couple months lined up. So, and Robert sends out an email with the Zoom to everyone. So that's all.
Thank
Great,
you.
thanks,
I think
Julie.
you meant propolis,
What did I say?
pollen.
Oh, yeah, I meant propolis. But doesn't he do that pollen thing that you do? But I meant propolis. But anyway.
Yeah, he does pollen, but he's well better known for propolis.
Yeah.
Cool.
And I want to encourage everybody, if you're not a member of, NEKBA, please consider joining. It's only $15. It goes a long ways, really helps bring in some speakers. And then as Kansas honey producers as well. Cheryl just put the link in there to the Kansas honey producers. Be a member there. There's a lot of good information. What else? Anybody else have anything good for the cause?
Yes, this is Tiny Jackson.
Hey,
Can you hear
Tiny.
me?
We can hear you.
Okay, I'm working off two computers. Computer, the microphone doesn't work, the other one does. So I'm sponsoring hosting a beekeeper swap meet and farmers market August the 6th in Burlington, Kansas. It's in Kelly Park, and that's in the fairgrounds in the southeast side of town, between 11 o'clock and 5 o'clock. Bring your bee equipment, your experience, your ideas, and don't bring any bees. No bees allowed. You can trade bees later. This is sponsored by the Kansas honey producers. And if you would like to reserve a spot, I have 20 spots available. Phone number 620-481-1275. And you can contact me up to August 5th. I cut out. Hello.
Yep, we heard. All good.
Okay. Yeah. Hope to see
All right,
somebody
thanks, Tiny.
down. All right. Bye.
All right, Robert, what else? Anything?
I'm done. Good to
Ed,
go.
Becky?
No, you're good to go.
All right, Dr. John, thank you so much. You've been a great speaker. I really appreciate it.
Oh, you're
And,
quite welcome. I'll see you in a couple of weeks.
All right, everybody else, we'll see you in a couple of weeks for our Q&A. Don't forget, we have a monthly Q&A. Robert, you raised your hand.
What are the details on EAS? Who, when, and where? How much?
Eastern Apiculture Society. It's being held the first week in August in Ithaca, New York, this year. It's a week long. They're back to their normal format finally for this year. So there's a bit of a short program at the beginning of the week and then a long program towards the end of the week. So they're bringing in a lot of a lot of national speakers. Like I said, John will be there. I know. I tried to get him to give the talk he's giving there to us tonight. I don't think he was quite ready. So,
Hey,
but
just to bring it up, so in this 3rd edition of Larry Connor's book that just came out,
so
chapter
you do
7,
have the 3rd edition. Okay.
yeah, chapter 7 is all about pheromones on there, and there were some in this talk tonight that aren't in the book. So, yippee!
Well, we're saving that for the 4th edition.
Okay.
Got to keep you coming back.
Well, there aren't many books that have pheromones about in there, and a whole chapter dedicated to it. So, Cheryl and I were going to brush up.
Where'd you get the new edition, Robert?
It was a gift.
Ah, okay. You know somebody?
Well, if you come to EAS, you can get one autographed by Dewey Karen.
Hey, I may bring it along.
Yeah, no, I'm looking for it. It should be a good week. So,
Robert, are you going?
You know, I think with that and the fair, I can't do it. So, but
did anybody go to anybody go to the Heartland? I know Christy was going to try to go, but I think she said she couldn't make it. I'm just curious because that was in like Indiana, I think.
We did not go.
Yeah, a week or two ago. Okay. Yeah, I mean, if anybody has an opportunity to go to some of those local conferences, the Kansas, Jolie, do you know when the Kansas Honey or Jim, when's the fall conference for the Kansas honey producers in Salina? Do we have dates for that?
The first weekend in November.
Yeah, November 3rd.
Friday and Saturday.
Yeah, it's, anybody that's on the call, the conferences are really good. We've had, Jamie Ellis, Dr. Cameron Jack was there. There's a lot of networking, you get to meet a lot of fellow beekeepers. I met Tiny there. He's one of our beekeepers that lives kind of southeast of us or southwest of us a little bit. So really encourage you guys to get an opportunity to attend some of those conferences. Missouri State has a pretty decent conference as well.
Yeah, they're going to have theirs in Cape Girardeau this year. Missouri is.
Oh, wow. Clear down in the boot heel, huh? Okay.
Yeah, it's usually further or closer to us, but this year it's going to be down Cape Girardeau, and I don't remember the dates, but it's October. I don't remember exactly. We can look it up though, but yeah.
Okay. And then Cheryl put in the chat that our monthly Q&A is August 1st. It's a great chance to get in and just ask whatever questions you have. I did see someone ask about herbicides. So maybe we'll have a future talk on pesticides and herbicides, but that's something we can bring up in our monthly Q&A. All right. Well, I don't have anything else. So we will close the meeting for the evening. Thanks everybody for attending.
Good presentation.